Okay, we're going to go and get started. Hi, everyone. My name is Kelly Dudley, and I'm with the News Center. I'd like to welcome you to today's webinar entitled Heidelberg Materials, a Profile in Leadership for Decarbonizing Concrete. And I'm so glad you could join us today. A video recording and PDF of today's presentation you're about to see will be uploaded to the new website, newconcrete.org, following today's webinar. Questions can be asked in the Q&A dialog box of Zoom. It will be answered once the presentation is finished. Attendees are in listen-only mode. The ideas expressed in the following presentation are those of the speaker and do not necessarily reflect the views of the News Center, ACI, or its committees. As with all concrete mixtures, trial batches should be performed to verify concrete properties. Results may vary due to a variety of circumstances, including temperature and mixture components, among other things. You should consult your materials, cement, and concrete professionals for design assistance. Nothing contained herein shall be considered or construed as warranty or guarantee, either expressed or implied, including any warranty of fitness for a particular purpose. Okay, now I'd like to introduce our speaker today, Larry Rowland. Larry is the Sustainability Market Manager for Heidelberg Materials. He's an accomplished speaker with more than 35 years of experience in the construction and concrete materials industries. Larry recently celebrated his 20th anniversary of being recognized as Lead Accredited Professional. He regularly consults on sustainable solutions with owners, architects, engineers, students, and green building practitioners, with a special focus on the topic of low carbon concrete. And now I'm going to go ahead and pass it off to Larry.
Thank you very much, Kelly. I appreciate the introduction, and I welcome everybody to the presentation. Heidelberg Materials is very pleased to be a member of NEW, the ACI Center for Excellence on Low Carbon Concrete. Today, I want to give you, first of all, I'm going to give you my outline of what we're going to talk about, and then, of course, I'll go through it. And then at the end, I'll be glad to take any questions that come up with that. So we're going to talk about why it's important to decarbonize concrete, why we're all here, what is the point of NEW, what's the reason why it's such a focus for my company and the industry in general. We're going to talk about how the industry is approaching the topic of getting our environmental footprint lowered and lowering our embodied carbon. And then what Heidelberg Material is doing to really play a leadership role in that, and how we're applying technology. Specifically, I'm going to go into some detail on carbon capture, utilization, and storage, and how that works and what that's about. I'll talk certainly about the availability of Evo Zero, which is a new product that's available in Europe that you're able to purchase and essentially have a net zero cement without offsets. You're not paying to plant a tree somewhere. You're actually within the value chain of the concrete and cement industries with that product. And then I'll talk about the levers that we have available to us today in decarbonizing concrete. And then, of course, we'll get into Q&A at the end. So the reason that we are so engaged and the reason that NEW exists is because concrete is such an important building material. It is the world's most widely used solid material. After water, it's the world's most consumed material. It's pretty much everywhere. We all depend on it daily for our modern society. And the reason it's there is because it delivers great economy. It's structurally sound, it's durable, it's resilient, it lasts a long time, it's very versatile, and of course, it is, a great benefit to us to have this building material that is so reliable. Because it is the most widely used material on Earth after water, it has a significant environmental footprint. And specifically, the thing that people are focused on a great deal now is our carbon emissions. The concrete industry is responsible for 7 to 8% of all man-made CO2 emissions. That is perhaps considered a pretty good trade-off for the amount of concrete that we consume on Earth, but it is a fairly significant number. So we want to improve that and, reduce that as much as we possibly can. So concrete is going to be, a big part of pretty much any building, especially like commercial buildings. The concrete that's within the building will account for a very large portion, typically, of the embodied carbon in a structure. And this is a flow chart that kind of demonstrates this. You can kind of see where the different materials are. Here, the concrete in this example is right about 50% of all the carbon flows, or all the embodied carbon within this building. Steel, glass, some of these other materials are there as well. But you can see the embodied carbon for a building can be quite substantial when it comes to the carbon emissions associated with concrete. And so that is very much a center focus for the design industry, for the building materials industry. And that is very much why we're taking this so seriously, and why we're working very hard to decarbonize concrete. So it's important that everybody gets on the same page of where those embodied emissions come from. The cement binders that we use will account for 85% plus. Typically, in this example, we've got almost 88% of all the carbon emissions associated with this particular concrete mixture come from the cement binders. The aggregate, as you see, is about 5% or less. The CO2 associated with processing and harvesting and getting those aggregates and delivering them to your ready-mix plant are still only about 5%. Likewise, the logistics to deliver the concrete to a ready-mix concrete to a project site is also typically below 5%. And then, of course, there's power, and there's other materials that we're putting on our mixes. So, we're zeroing in on the cement, on the binders, because they play such an important role in the embodied carbon for concrete. The industry as a whole recognizes that large piece that we play in concrete. And so the Portland Cement Association developed its roadmap to carbon neutrality. Heidelberg Materials was a part of this. We're an active industry member, and we worked together to help create this roadmap so that we can plan a way to reduce our carbon and to get to carbon neutrality. The big 5 things that we're looking at are cement clinker, the finished cement that's supplied to projects. Concrete, of course, is the material that everyone will typically use and associates with our industry. The construction, there is certainly a big piece of how we construct our buildings, et cetera, which will affect the carbon footprint for that project. And then carbonation, which is a naturally occurring uptake of carbon that concrete does all the time. Likewise, the European CEM Bureau, which is the European Cement Association, has a very similar structure, a very similar set of goals. They actually just recently this month published their 5-year update to their carbon neutrality roadmap. They have essentially the same 5 key levers. And so you see the consistency here of everyone recognizing what it is we need to do to reduce our carbon footprint. With clinker, carbon capture, utilization, and storage is featured very heavily in CEM Bureau's plans for how we're going to reduce our carbon and the industry's approach. I'll talk about that in more detail. We also want to lower our clinker factors in cement. We want to improve our concrete mixes. Of course, we want to work with our stakeholders and our customers so that we can reduce the carbon by our construction methods, and then carbonation is a naturally occurring event like we talked about. So, what is it that industry is doing to respond to these plans? Well, Heidelberg Materials is active, like we talked about, in the industry. At the cement plant, we're working hard to reduce the amount of CO2, which is embodied in our cement clinker. We do this by having very efficient cement plants. This is an example here. We just recently had a ribbon cutting at our Mitchell plant last year in Mitchell, Indiana. It's the second largest cement plant in North America, and it's super efficient. I mean, the whole goal of building this plant and the whole goal of reinvesting in our industry is so that we can produce our cement clinker with the least amount of fuels in the most efficient ways as possible. And that, of course, equates to a reduction in our carbon. The other thing that we do is we're reducing the amount of cement clinker that is within our cements. I'll go into that in some detail. So essentially, the idea is that we're reducing the high carbon component, which goes into the cement, and that indeed will help us reduce our carbon footprint as well. I'll go into carbon capture, utilization, and storage, but it is an important part of how we're going to address the embodied carbon within cement and clinker. In concrete, the key is to utilize the tools that we have available today, and that is supplementary cementitious materials, do things such as like aggregate grading optimization, and then also embrace digital solutions. I'll wrap up my presentation today with an explanation of what I'm talking about there. Essentially, we're using AI to enable good decision-making and to improve our efficiencies. And then, of course, it's very important that we collaborate with our owners. It's hard to understate or overstate, I should say, the importance of working together with all the stakeholders associated with a building project. And then natural sequestration of carbon is the carbonation piece that we keep talking about. So Heidelberg Materials is a big industrial player. We're one of the world's largest building material companies. We've got over 50,000 employees in more than 3,000 locations worldwide. And we have leading positions in cement, aggregate, and ready mix. So, you know, when we make these moves and the things that Heidelberg Materials is doing make a big difference. We're talking tens of millions of tons of savings of CO2 because of the steps that we're taking to reduce our carbon footprint. And of course, we will be the first company to have a large-scale CCS plant in the world. In North America, we've got about 8,500 employees. I want to shout out if there's people out there who are interested in working with a dynamic company, please come and talk to us. We've got a good place for you. And we've got quite a bit of different materials that we supply, of course. In 450 locations, we've got cement, supplementary cementitious materials such as slag and ash. We have a great deal of aggregates throughout the company. And then, of course, we also have ready mix and even asphalt. So, you know, we're very diverse in the heavy building materials industry, and you can see our footprint there on the map. When we approach sustainability, you basically have to have a plan. The old saying about how if you don't have a plan, you're planning to fail. We have great plans and we have great commitments. We have stepped up and said, look, this is how we're going to get to a net zero concretes. This is how we're going to reduce our environmental footprint. We're going to utilize an approach to reduce our carbon. That's our net zero commitment. We are going to be inclusive and safe in the way that we do our business. We value our people. As you know, people make it happen. So we value our people a great deal, and we want to enable our people to not only be safe and secure, but also empower them to help us make these changes that we need to make. Of course, we need to be nature positive, which is to contribute wherever we can and reduce our environmental impacts. And then, of course, embrace the circular economy. Think recycled materials when you see that term. Our goals, we're an international player, as we said, and as a corporate citizen, we've embraced the approach that comes from the science-based target initiatives. which is essentially the group that's out there that is helping people to evaluate whether their plans are aligned with the Paris Climate Agreement to reduce global warming to 1.5 degrees Celsius. So we went to them, we've presented our plans, we've gone through and worked back and forth and come up with the commitments that we've talked about. And those are the world's most aggressive within our industry. This 400 kilogram of CO2 per ton of cementitious material is, like I said, the globe's most aggressive reduction in carbon for cementitious materials. For an example, so that you understand the scope of this, a industry average ton of Portland cement, according to the PCA's EPD for the industry average, is over 900 kilograms per ton. So you can see how getting down to 400 kg per ton is a big step. We're going to have to work very hard to do that. We have to invest in alternative materials. And of course, we have to be very efficient in the way we make our cementitious materials. The other things we're going to do is we're going to reduce our overall emissions by almost 50%. You can see here we've committed to a 47% reduction in that by 2030. And all these goals are by 2030 here, 6 quick years from now. We will be producing 50% plus of all of our revenue will come from sustainable products, low carbon products. Namely, are the kind of things that we're going to be embracing within our company so that we will reduce our impacts. And then the big number here is this 10 million tons of cumulative CO2 reduction through carbon capture, utilization, and storage. And by doing these in a very long list of things, we are going to be in line to and as verified by the SBTI, the Science Based Target Initiatives, we will help the globe as a whole reduce that global warming. So the carbon capture and storage, that big number like we talked about, that 10 million tons, will be coming from a whole host of different projects. I'll talk in detail about the very first one here. You can see in 2024, we'll be operating our plant in Brevik, Norway. It'll be commissioned in 2024. People are working very diligently to make sure that that happens. And it'll be in operation and truly underway by 2025 and capturing carbon and storing it in an efficient manner. In 2026 is in Edmonton. You can see up here, I'll talk about that. And then you can see across the board here, we've got a variety of different projects. These projects are embracing different technologies. The primary technology that is matured currently, you can see we've got a green bar and maturity here for the amine carbon capture and storage technology. This utilizes an amine solution, which helps us capture the CO2. I'll go into some detail on that. And of course, we're exploring and investing in multiple other types of carbon capture and storage. We need to find the most efficient, the most energy, the least amount of energy use, the most cost-efficient ways of capturing carbon so that we can really help decarbonize our industry and help revolutionize the way that this industry manufactures cement and binders for concrete. And we have oxy fuel-based projects underway, and of course we're also doing a LELAC 2 projects. So we're across the board building and working at different technologies to find the very best ones that are going to help us sequester that 10 million tons. The very first, most mature technology now is the amine technology we talked about. That's underway for Brevik, Norway. In Brevik, it will be the very first industrial scale carbon capture and storage plant on Earth. We're very proud of that plant. Like we said, that'll be operational here by the end of this year. And once the plant is operating at full capacity, it will be capturing 400,000 tons per year of CO2. So every year, the capacity for this plant in Norway is 800,000 tons plus, plus or minus, and about half of all its emissions, 400,000 tons a year, will be captured through this process. This makes possible the sale of EvoZero cement, which is available in the European market for a couple different ways. So basically, it's the very first net zero cement that's available without buying something out of our value stream, some offsets or something like that. We're doing a mass balance approach. So in other words, since we're capturing roughly half of our emissions, you would be able to buy, we could only sell that many, right? We can't sell a full 800,000. We can only apply and work with our customers to claim EvoZero on the portion that is associated with those with that CO2 capture and storage. A very rigorous accounting process, and it's all very much transparent. Everybody can see exactly how that works. It is, like we talked about, the first site here on Earth, and we're working very hard to work with our customers to make this material available, and of course to book, use book and claim technology and to utilize a very transparent process so that EvoZero is available to our customers. The very next big project that we're doing, which is also an amine system, is going to be in Edmonton, Canada. This is in Alberta, north of Calgary a ways, a few hours north of Calgary. And this is going to be the first full scale. As we talked about, Brevik is roughly 1/2 of their production of CO2 that is generated associated with their cement production. Essentially all of the cement production having to do with our production in Edmonton, Canada will be captured and stored in that process. Now, this is a flow chart that explains how these amine systems work. Each and every carbon capture and storage system at any cement plant will be different. They're not all the same. They're all unique. But in general, this will give you a good feel for what happens in these systems. So the cement that is sold will be the same. We want to start with the very lowest carbon cement as we can. We want to sell that to our customers. We're doing that currently. Our customers, when they're buying this cement in Edmonton, won't see any difference in the cement. All the activity associated with carbon capture and storage happens at the stack, essentially at where we would release CO2 as part of our gas emissions for the plant. That material, all of those emissions will be diverted, and the CO2 is separated from the gas stream from our exhaust stack. That CO2 is then run through an absorber. The CO2 is taken out of that gas stream and captured. It's separated with an amine solution. It is then circulated into a second chamber where the CO2 is desorbed, or it's stripped off of the amine. We have to apply a good deal of heat to make that happen. Then we have pure CO2, which can be injected and stored in the ground. Now, to make the heat that is required for this desorber to work, we actually are going to have a combined heat and power plant. Now, hang with me, guys. I know that this is pretty technical, but what happens with this combined heat and power plant is we're generating heat, which is used for the process to release the CO2 from the amine solution. And in doing that, the heat that is generated is used to make power. So it's not just waste heat. The heat is used to generate electrical power, which is then sourced to supply the plant. And then it's sold, whatever excess power that we will have is going to be sold to the local utility consumers there in Alberta and in the Edmonton area. An important thing to understand is that the exhaust from this, the CO2 generated from this combined heat and power plant, is also captured and run through the system. So any CO2 that's generated for that becomes part of the overall capture strategy. So when we talk about net zero cements, and the way that the accounting happens, everything has to be very transparent. So we have to work with life cycle assessment experts and professionals to make sure that our accounting is done exactly above board and with transparency. So essentially what's happening in this flow chart, as you can see, the emissions associated with our process are in the blue bars here. Process emissions are, I'll talk about a little bit later. They're the largest piece. There's combustion emissions, that's the next biggest piece. And those are offset by biogenic burning biomass and alternative fuels. Carbon capture, utilization, and storage picks up the biggest piece, which is bringing those numbers down. And then, of course, the net impact is we're going to get down at zero, below zero, or very near zero, which is our goal, right? This is where we get to start. Then, of course, ready mix, which would buy or any concrete that is a producer that buys that cement, would then take that cement that has essentially zero or even below zero for their embodied CO2 and apply it and be able to get down here where they have a net zero concrete. Today, those concretes are up and around 225 kilograms per meter in Canada. And then, of course, in the United States, we calculate it by kilograms per yard or pounds per yard. But either way, the point is that because you're starting off so very low, it's very easy to keep those numbers very, very low and or even get down to a net zero. Okay, so I know that that's a whole lot of detail, but the question that always comes out of this typically is what happens with the carbon capture and the CO2, how is it stored? Well, an important key feature of this process is that the CO2 is stored with a measured, monitored, and verified storage approach. This is all highly regulated by the province of Alberta, and it is verified and monitored to the point where we know exactly what's happening with that CO2. The CO2 is injected down into the ground about 2.5 kilometers in our case, and that material has to be in a very specific aquifer that will accept the CO2. We have to also, the other things that we have to have in place are layers of cap rock. In other words, we have to make sure that these geological deposits will accept the CO2. The CO2 will be there as a permanent storage, and we don't have to worry about that material coming back up. That's where the monitoring and measuring comes up. We're going to measure the CO2 as we put it in the ground, and we're going to monitor it to make sure that we're not losing any pressure, or that the material is being absorbed into that saline aquifer and mineralized, etc. And so the material will be stored essentially permanently. The next big project that we're looking to do here in North America is to apply carbon capture, utilization, and storage to our plant in Mitchell, Indiana. The plant I talked about as being this very efficient new plant that we built in Mitchell. We've already received a very generous grant from the DOE to pursue this technology so that we can do carbon capture and storage in the Mitchell plant in Indiana. And you can see here the plant, we're looking at a couple million tons per year of storage there. It's a larger plant. It'll be, it's more efficient already. And we're going to go ahead and capture essentially all the emissions that we can in Mitchell. The goal is to get we're very near 100% of those emissions. To make this happen, and the thing that's going to enable the industry to embrace these technology, of course, is to build these plants, to learn how to do them effectively, to learn how to do them cost effectively, and certainly efficiency associated with capturing the CO2. We need to have those class 6 wells, which are the right geological formations, like I talked about. We have to make sure that that infrastructure of the pipelines and the wells themselves are in place so that when we capture the CO2s, when we capture this carbon emissions, that we have a place to put it and that there's infrastructure to accept it. And then, of course, it takes a significant investment to do these projects. So cement is not the only thing and the only approach. It is a big focus, like we talked about, because of the proportional embodied carbon associated with it. You can see here under our cement, we've got the EVO 0, which is the cement associated with that carbon capture and storage. But of course, we also have our EcoCem PLC and our EcoCem Plus cements. So these are reduced low carbon cements. We have EvoBuild concrete, which is a low carbon concrete. We then extend that out into our aggregates and asphalt as well. Since concrete is the material that most people are buying, these concrete are perhaps the things that you'll see out in the market right away. And the EcoCem Plus or the EcoCem PLC enable the EvoBuild concretes. So when we talk about having a low carbon cements, we want to talk about clinker factors. I mentioned clinker several times. Clinker is the material that we manufacture in our kilns. It's the material that the cement factory essentially makes. That's the big energy and the big CO2 emissions come from manufacturing clinker. Portland cement has a clinker factor of 94, 95%. Portland limestone cement has a reduction of about 10% below that. This is a 12% reduction in this example here. So EcoCem PLC will have up to 15% limestone, which helps us reduce our clinker factor. And then blended cements, which have not only limestone, but also in most cases, a supplementary cementitious material such as slag or ash or some of these other materials incorporated in that. We're going to get this clinker factor down much further. We have slag cements where that clinker factor is down well below around 50% or a little bit below 50%. So these are innovations that we're able to use. These cements are all manufactured per specification. They are very much, structural. They're used every day. They're products that you're used to here in North America. There's been a great deal of push to bring Portland limestone cements to market. So they're the kind of things that you're already seeing out there. I talked a little bit about our carbon footprint for cement. It's important that people understand that 2/3 of our CO2 emissions or our carbon emissions associated with manufacturing clinker come from heating up the limestone. It's a natural process. When you apply heat to calcium carbonate, which is another name for limestone, you generate calcium oxides and CO2. The calcium oxides are bound up with silica compounds in most cases, and that's essentially what we're capturing to make our clinker. And the CO2 is a byproduct from that process. 2/3 of our emissions come from these process emissions, and that is something that we really can't change. Our 1/3 is where the efficiencies come in. This is where alternative fuels, grinding efficiency, burning efficiencies, and utilizing the right raw materials, et cetera, all help us reduce that piece of our emissions. So kind of as a review here, when you were looking at generating or producing these low carbon concretes or these low carbon cements for your low carbon concrete mixes, we are very much doing a lot of trials to make sure that the product is ready for market. We've gone through, and you can see for the example that we use for our type 1L or Portland limestone cements, this is the kind of testing that we've done here in the years leading up to selling Portland limestone cements throughout the Midwest. We were able to verify and make sure that our cements would do the job that you expect them to do. Another neat product, and it's a little bit of a specialty thing here, is our TX Active product. This is a photocatalytic cement. The amazing thing about this cement is it actually is like they sometimes call it a smog eating cement, because it will actually mitigate NOx. It will pull NOx right out of the air through a photocatalytic reaction on the surface of the concrete. And through that process, it has what they call the Lotus effect. So it is not only is it cleaning the air and scrubbing the air from smog generating NOx, but it's also self-cleaning. It actually has what they call the Lotus effect, where the concrete itself actually cleans, and it's in a kind of self removes the soot and soiling that can accompany the surface of concrete. So getting back to concrete, so in our low carbon concrete, the keys to a successful low carbon concrete mix is to choose the right cements, like we talked about. Utilize a low clinker content in your cement. Make sure that the clinker is made very efficiently. Optimize your area gradations, like we talked about, and dial in your mixes so that they're very efficient. Utilize AI tools, and then of course work together with the project stakeholders. I talked about this a little bit earlier here. EvoBuild is Heidelberg Materials low carbon concrete brands. It's set up pretty straightforward. If you get an EvoBuild bronze, if you wanted to order EvoBuild bronze, you're going to get concrete that has a 30 to 50% reduction in CO2 versus a standard baseline. That baseline was set by the 2021 Carbon Leadership Forum baselines, which the NRMCA has embraced. For instance, EvoBuild silver will be 50 to 70% reduction, and then gold is 70 plus. So what those numbers mean when you start actually cranking the numbers and you start looking at the evaluation, it's pretty straightforward. We take the benchmark, which are listed here inside this box. You can see for a 3000 PSI mix, the benchmark GWP, or the benchmark embodied carbon for that mix, is 291. We reduce that by 30 to 50% to sell a bronze product. Therefore, our global warming potential for these mixes will have to be below 204 up to 145, right? 203.7 to 145.5, etc. So it's very straightforward. It's very beneficial. The neat thing about this is we can show it on our EPDs. You can see very clearly what the GWP associated with our mixes are, and you'll see just by the name of what we're selling you that material is going to be a low carbon concrete. To get there and to make these mixes low carbon, we're going to go ahead and utilize supplementary cementitious materials to a great degree. As ACI defines these materials, they're essentially something that reacts positologically or hydraulically within the mix. They will almost always react with calcium hydroxide, which is a hydration product from within the Portland cement system. They'll be combined in there, and we will reduce our Portland limestone cement or our Portland cement binders by replacing them with these supplementary cementitious materials. Most of the time here in the United States or in North America as a whole, these supplementary cementitious materials would be fly ash or slag. Like we talked about, ground slag or ground granulated blast furnace slag cement for short, or just plain slag, is a really terrific material because you can get very high replacements of that material into your mix. Coal ash, often referred to as fly ash, and we're reclaiming those materials now. That is also very beneficial and very widely used SCM. In North America, these are essentially considered to start from where they are produced at having essentially a zero CO2, embodied CO2, because they are waste products from other industries. So that makes the CO2 global warming potential associated with these materials very low. The embodied carbon in these materials is very low. It helps us reduce our carbon footprint for our mixes. And the neat things about them is they improve our mixes. They improve concrete mixers. They can make them stronger, less permeable, less susceptible to chemical attacks and ASR and those kind of things. So the ins and outs of these two important products are for instance, with slag, slag is a waste product from the blast furnaces, like we talked about. This is actually, you can see the different materials are being tapped off from a blast furnace. The slag material needs to be quenched. It's a byproduct from that iron processing in the blast furnace. It has all the right chemistry, but if it's air cooled, slag becomes inert. It's essentially just a stone or something that is often landfilled because it has very little value as far in the market. It's just a porous rock. Well, if we are quenching these and we install a granulator in our in some of these blast furnace operations, that then becomes these valuable slag cement materials. That's the key to making slag reactive, is to install a granulator and to have this material converted to a cement-like material. And we're working very hard to make sure that we access all the blast furnaces in North America, and that we make sure that granulators are installed in those operations so that slag cement can be produced instead of something that would otherwise just be wasted. In fly ash, people are very familiar with fly ash in most markets. Fly ash is, like we talked about, or coal ash. It's a coal ash. It's a coal residual from burning coal at a power plant. These coal ashes have been utilized for many, many years, but there was historically much more fly ash or much more coal ash generated than the market could consume. So these materials were landfilled. That represents a really good resource now moving forward, because as fly ash and as these coal burning plants are converting to electric or some other applications, or I should say they're converting to a different types of fuels. An electrical power plant will convert, for instance, from coal to gas feed, or gas powered, or burning natural gas versus coal. The fly ash, it goes away, right? So what happens is they have over 1 billion plus tons of landfilled coal ash, which is in place now in North America. That represents a resource to us if we use the right technologies to beneficiate that ash and make it useful in concrete. Fortunately, we acquired the CEFA Group last year, which has 47 years of experience in marketing and selling ash. They have the STAR technology, and that technology enables us to go into a landfill and beneficiate that ash, pyroprocess it, thermally process it, I should say, and that ash then becomes very consistent and a very good SEM for concrete. And we have 40 plus years at least of resources out there in landfilled ashes that we'll be able to tap into. And finally, I promised that I'd talk a little bit about digital technologies and how that helps us be sustainable. We're embracing this in a very big way. Our ready mix operations have in place, we have in drum monitoring from, we know what that concrete is, we know where it is, and we know what it's like. And we're able to track that material all the way to the project site. And then we're embracing maturity monitoring, which helps the designer have faith in understanding what's happening in the mix. So in these truck monitorings, essentially it's a probe that mounts into the side of the drum, and it tells us exactly what's happening with that. We know how the mix is batched. The probe will tell us what the slump is. We can make adjustments at the plant, and then that way people aren't tempted to get to the job site and then add a bunch of water. So the concrete gets better as far as our quality control. And of course, then we have the monitoring, all the data that we're collecting from that will help us in the future make good decisions as well. And then it helps the customer because they get to see exactly where that truck is, et cetera. Maturity monitoring is associated with basically you run a strength gain curve, and you know exactly when the concrete is getting to the specified strength. You don't have to wait to break cylinders that may have ended up getting left out in the elements, and or maybe not picked up correctly or managed properly. Instead, you can utilize maturity monitoring with these in-place probes that will tell you exactly, you have an app on your phone, it tells you exactly how strong that concrete is. So if you're waiting to strip a column until you get to a certain strength, you know exactly where that is. So between these two things, where we're utilizing the in-truck monitoring through our probes and through the maturity monitoring, which is all enabled through the web and through the cloud-based technologies, we're able to monitor our concrete and understand it all the better. And then that is what really drives change for our customers, our owners and specifiers, because that gives them confidence. They're able to utilize specifications that are looking for performance, and they tell us what it is that they need when, and we can give them the right mixes with a very low carbon, embodied carbon associated with those mixes. The performance specifications enable a tremendous amount of innovation by the concrete producer, right? The other thing that we'll do is like we talked about, we're gonna continue on this path of having lower clinker contents in our cements. And of course, we need to work with our customers to make sure that they're on board with that and that everybody understands the impacts to the schedule and what it is that we can do to make adjustments. We won't necessarily have the same global warming potential for each mix. So work with the customers, make sure that everybody understands the targets, and then we're able to make some great inroads and reductions in our carbon footprints. So it looks like we have some time for some questions. I appreciate everybody's attention. Thank you very much. If you need to reach me, here's my contact information. I'll just leave this up here a little bit longer.
Okay, thank you, Larry, so much. That was a wonderful presentation. We do have a few moments if anyone would like to ask questions in the Q&A box. We have a few in there, but if anyone would like to add a few more, that would be fine. And we have Sareka, who is also with the News Center, that will read some questions out loud that Larry can go ahead and answer.
Yep, thanks, Kelly. Larry, thank you so much for great presentation, great information, and thank you for your support to NEO and also all what Heidelberg Materials do to reduce carbon emissions in the industry. We have 3 questions at the moment. The first one, have you considered recycled glass powder for SCM?
Absolutely, we have. And we have some of our ready-mix operations have certainly used it. We have worked with those producers. We've certainly given them our cement and to make sure that those materials work well together. That is a neat technology, and it can be very useful because as other SCMs, this is a waste product. And what happens with that typically is you're going to take a post-consumer glass or sometimes even a post-industrial glass source, grind it up very fine so it becomes reactive with calcium hydroxide like other SCMs, and it can do very good things for your concrete. Its availability is somewhat limited, but it is a neat product, and it can do a lot of it can certainly beneficiate your mixes. It can make your mixes better, and of course, it reduces your carbon footprint.
Great, thank you. Next question is, how do you roll out your new cement blends like EcoCem Plus 1T? Do ready-mix producers have to install additional silos? For aggregate optimization, do producers have capacity to implement this, or is it easily added?
So right, there's a couple different questions there. So for the cements, whenever we're rolling these cements out, we've worked very hard with our customers to make sure that they know what to expect. You should insist on this from your cement companies. We certainly have worked very hard to do this. Essentially, what you need to do is to dial in your mixes, and then typically what will happen is people will make a conversion. If they wanted to go from Portland limestone cement to a blended cement, an EcoCem Plus versus an EcoCem PLC, typically you dial in your mix, get together with your suppliers, not only a cement supplier, but also work with your admixture suppliers, Dial in your mixes, make sure that you know exactly what to expect, what adjustments you need to make. Every time you make a change in cement, you should make adjustments. And then typically what will happen is we're going to say, okay, on this date, we're going to pull the lever and we're going to change. So you don't necessarily have to have separate silos at all. A lot of times people will just convert their operation. If you happen to have an extra silo, that's great. Most of the time when people have additional silo capabilities, they will use that to stock SCMs. They'll typically put a slag or fly ash or another SCM in a silo to have the flexibility to have different SCM levels within their mixes. As far as aggregate goes and optimizing your aggregates, that's all about working with your aggregate producers and making the right selections. Just as everybody knows who's involved with this business, just as we need to make sure that our fine aggregates don't get too fine, they don't get too dusty or dirty, a lot of times is the way we call it. Work with your supplier and make sure that you have the gradations dialed in where you can. Most of the time, it isn't a tremendous change. Usually, you're still combining a couple. You may have to add if you're only using a single aggregate and a very basic approach to your mixes. Every time you add additional aggregate in different gradations, you give yourself flexibility, and that's where you're able to actually dial this in and say, okay, I've got everything from my very fine aggregate all the way up to my coarsest aggregate. I want to fill all the gaps wherever I can. So having those different aggregate sources will help you multiple bins, work with your aggregate suppliers, and that can make that happen.
Great explanation. Thanks, Larry. The next question is, are there any tools or calculators that you recommend for life cycle assessment?
Right, the GCCA has a very good tool out there. We utilize these materials like we talk about. The way that we illustrate and that we have transparency for these products is through environmental product declarations. The EC3 tool is a very good one that is essentially a database of EPDs. So yeah, there's lots of good tools out there. The NRMCA has done a lot of great work on this. GCCA tool. So yeah, there's multitude. I don't have a specific favorite. I guess if I had to pick one off the top of my head, the one that I'm going to learn the most about and become the most proficient at is the GCCA tool moving forward.
Excellent, thank you. The next question, will the slides be available? That's for us, yes, and the recording will be available in the website. For you, Larry, when will the Mitchell plant CCUS be online?
So the Mitchell plant is still in very early stages. We're doing our FEED study now, which is the forward engineering and study right now. Excuse me, I forget the right acronym. But the Mitchell plant is underway. We're doing the research to make sure we're currently evaluating class 6 well locations and sites that we can do that. And as we talked about, that is a very detailed process and highly regulated. So we're working with the regulators within that area to make sure that we're able to do these things. So that process is by 2030 is our target, is to have Mitchell online and the CCUS operating. So first is Brevik coming online this year. Edmonton, we're targeting 2026, 2027, then Mitchell to roll in after that.
Perfect. Next question. You mentioned slag. Does Heidelberg have access to any US or Canada-based granulators?
Absolutely. Yeah. Heidelberg Materials is working very hard to become North America's largest slag supplier here to the market because we recognize its important role it has in reducing carbon in concrete mixes. The neat thing about slag, like I talked about, typically you'll start with about a 40% replacement of your Portland or your Portland limestone cement with slag. And so you're replacing a bigger portion of the cementitious materials with that SEM. So slag's a really neat product for that. And yes, we're working very hard to secure North American sources of slag granules. Another neat thing about slag is it reacts very well with Portland limestone cements. You actually get a little bit more bang for your buck when you're adding slag with a Portland limestone cement than you would just a straight Portland cement. And since the market is going to Portland limestone cements, that's an added benefit associated with those materials.
All right, thank you. And this question has two parts. The first one is, are your EvoBuild concretes available across all your territory now?
So yes, all of our ready-mix operations, you can get EvoBuild products. You can get an EvoBuild concrete mixtures at any Heidelberg Material ready-mix operation. If they say any different, give me a call, and I'll be glad to chase that down and make sure that happens. But no, it is happening everywhere that we sell ready-mix concrete. The EvoBuild products are available.
That's great to hear, Larry. And can you give us some idea of the cost premium for the various levels so we can plan our projects? I mean, related to the first question, of course.
Yeah, you need to connect with the local people. I can't make any cost predictions, but typically with these materials, the cost implications, excuse me, for a project are very low. So the overall cost for a building for going with these green mixes and having an aggressive carbon reduction budget for a project budget, even if you're lowering your carbon footprint for your whole job, for your building or your highway, whatever that system is, we're talking 3 to 5% typically, and that's going to include pretty much all the efforts you need to do, just verification, organizing, and collaboration efforts and all that. So overall, it's a very small cost typically, and you'd have to check on specifically what the different costs of the mixes are. I don't have a good handle or a good answer for you on that, but certainly they're very reasonable, especially when you consider the role of concrete in the overall cost for a project.
Excellent. We had two more questions. You classified low carbon concrete into 4 groups: bronze, silver, gold, and zero. Are other properties of concrete such as durability affected by reducing carbon content?
Yeah, absolutely not. We actually I had a conversation with a researcher recently that asked about technology ready materials. Everything we sell has to meet the structural expectations and the durability expectations and the resilience expectations that we set for concrete. There's no penalty for going with these low carbon mixes associated with the strength classes and the durability classes. It's still meeting the code. It's still doing everything that concrete needs to do. It's just doing it with a less embodied carbon. So no, anybody who's been in this business knows you can screw up concrete a lot of ways. And you could certainly do that when you're utilizing some of these other materials, but it's not inherent of the material. It's a matter of taking care of business, making sure that you do the right planning, dial in your mixes. And there's these mixes, for instance, with SEMs, they tend to be much more durable. They tend to have much less permeability, more abrasion resistance, etc. So yeah, these steps tend to improve your concrete, not hurt it.
All right, related to the same question, could you also provide a reference for this classification? I think you already discussed a little bit.
Yeah, I see. Okay, so in North America, the reference is that Carbon Leadership Forum, the 2021 numbers, because the neat thing about that is that it was a nationwide for the United States. In Canada, the reference we've chosen the Canadian Ready Mix Concrete Association's benchmarks. They're very, very similar, very close. It's just a matter of in Canada, they're starting with a slightly different a baseline of materials that are available to customers. So we've chosen, depending whether in the United States or whether you're in Canada, we've chosen a baseline that's a good set point for everybody. As the market evolves and as we get better and better at this, we should, we're going to see those baselines eventually move. But right now, those are the best things for us to point to.
Perfect. Our last question as of now, the 400 kilogram carbon dioxide per ton goal is impressive. Do you have a sense of where the US greenhouse gas intensity will be in 2030?
That is a good question. I don't know off the top of my head. That's a good question. So the where that 400 kg per ton number comes from is Heidelberg Material sells tens of millions of tons of cement, every year, hundreds of millions of tons of cementitious materials. So it's cementitious materials as a whole. So as the goal is to reduce the overall carbon intensity, we're doing that by our efficiencies in our Portland cements and our Portland limestone cements. We're also doing that by acquiring and developing these supplementary cementitious material. If you take a ton of coal ash that has a carbon footprint of 20 or 50, and for every ton of that you sell, of course, you're reducing a great amount, the overall average. So where we are in North America right now, boy, I should know that off the top of my head. I don't. But it is, I believe, as a company as a whole, we're in the 500s. I think I'd have to get that to you. But yeah, that's part of our reporting, and I can get that number to whoever asked that question. If you grab an email, I can follow up. But it's right now, it's globally, we're in the 500s. I know that much. So we've got a ways to go.
Thanks, Larry. Yeah, if you can forward, send you
we'll
answers.
Connect, you and me.
Yeah, we can post that as well. All right, I think those are all the questions we had so far, and thank you for answering all of them. And we are 3 minutes past by the given time. Kelly, you want to?
Yeah, I just wanted to wrap up and provide the information as to how to contact New. Please visit our website at newconcrete.org for more information on this topic. And while you're there, please check out the resources on lower carbon concrete production and placement. The website provides access to our sustainable concrete guides, FAQs, webinar recordings, and more. And like mentioned earlier, this recording will be up shortly on our new website, the PDF and the recording. And please stay tuned for our next webinar presented by Mike Schneider with Baker Concrete Construction, scheduled for June 27th. Thank you again for attending, and please stay tuned for new webinars in the future. Thank you, Larry. We appreciate it.
Thanks, everybody.